Here's sample test 4, problem number 3. A wire of length 1.8 meters and radius r equal to 0.01 centimeters is used to lift a physics book of mass 3 kilograms at constant velocity. If the wire stretches 0.02 meters in the process, what is the stress applied to the wire, the strain, and the Young's modulus? You know, if it's moving at constant velocity, then the net force on it is 0, and hence we can treat it almost like a statics problem. So we have the weight pulling down on this book equal to mg, and that would be equal to 3 times 9.8, which would be 29.4 newtons. And that would also then be the tension pulling up, because the tension and the weight would be equal because it's moving at constant velocity. So if we're talking about the stress is going to be equal to, either way you look at, the tension per area on the wire, which would be equal to the weight per area on the wire. Now the area of the wire is in turn equal to pi r squared. So that's going to be pi times 0.01 centimeters is 10 to the minus 4 meters. Square that. So this is going to be 3.14 times 10 to the minus 8, if I can fit that in there, meters squared. So our weight is going to be 29.4 divided by 3.14 times 10 to the minus 8 square meters, and that is equal to 9.36 times 10 to the 8 newtons per meter squared. So that is the stress applied to the wire. The strain is the change in length over the original length. In this case, it's stretched 0.02 meters, and the original length was 1.8 meters. So that is going to be 0.011, and no units on that. Meters over meters is no units. So this is simply 1.11 times 10 to the minus 2 with no units for the strain. It's just a fraction of how much it changed in relation to its original value. So now our Young's modulus is the stress over the strain, cause over the effect. So in this case, that's going to be 9.36 times 10 to the 8 newtons per meter squared over 0.011, and that is equal to 8.42 times 10 to the 10 newtons per meter squared. So presumably we could go into a table and figure out what this material was based on its mechanical properties of the Young's modulus, 8.42 times 10 to the 10 newtons per meter squared. And I feel good about that because we're something on the order of 10 to the 10.